All right, better now? In the back too? Okay, great. I'm not modest at all. So, I'm very happy to be here. You know, so when first I read about this idea, I forgot where I read about it, maybe staff told me or something. I thought, you know, this would be like, we come together, 20, 30 of us in Bristol or somewhere nearby for beer. You know, we get a nice room from a company who has empty rooms on weekends anyway. And we just chat, you know, there about R and, you know, nice things we did and so on. So I filled in the survey, you know, they had a survey initially that would you like Saturdays to happen? Would you want to help? What you could help with? Stuff like that. And I said, yeah, of course I want to go, I want to help. Yeah, I could present to, I never imagined it would be like 200 people, you know, sitting in the room. So I expected something a lot smaller, and it's great that it's happening and it's this big. And it's a great pleasure to be, you know, the first speaker here. I guess I should start the timer because otherwise Gergely will kill me. Okay, so I will talk about 4 things. I'm not sure how to get rid of the mouse cursor, so sorry about that. So first of all, I will talk about how, you know, I started using R and what I did in the past. This is not very technical, obviously, but just, I guess it's a nice, you know, format to some more technical things. And then I will talk about 2 technical things that I did. The first one is what I call the Metacran experiment. And the second one is the ARHA project. And then after that I will have some, you know, final thoughts, or it would have been an open discussion, you know, but it's impossible with 200 people. But anyway, so some just random thoughts about what I think about the future of R packages and R and so on, and what I see that we could, you know, do better, and what is good, what is not so good, and stuff like that. So what is my story? I have been an R user developer for about 14 years now. Unfortunately, I had a hard drive crash, so I couldn't find, you know, the first R code I wrote, which was in 2002. I could find it out, but I couldn't find the code. Maybe a good thing, actually, you know. I have a computer science PhD from the building next door, so it's kind of coming home, so that's good. Currently, I'm a consultant at a company called Mango Solutions, which is in the UK and does almost only R, basically. It's not exclusively, but because we have so many projects that are R-related that basically all my day job is doing R, which is amazing. So that is half of my time, basically, and the second half of my time is I'm the developer of the ARHA project, which is a big project of the biggish project of the R Consortium. I like making tools for data analysis. So I tried research. It turned out that that's not my kind of thing. I'm more into, you know, the process and the tools that you can use to do it, to do the actual analysis and to do the research. And maybe, I mean, probably if some of you know me, this could be a possible, you know, reason why I'm a co-main developer of this iGraph package. And if you use that, I'm really sorry and I apologize. Yeah. So, and several smaller packages. Don't make big packages, people. It's not good. Make small, you know, nice small packages. Okay. So in 2002, I was in the Netherlands as an Erasmus student. Like maybe many of you, or a lot of students at the time, you know, they wanted to use this opportunity to go to, you know, abroad. And I had a project there that I did, but that didn't really involve R, as far as I remember. But I also took some courses, and so this is the Technical University in Eindhoven, one of the buildings, a big building of the university. And I also took some courses, and one of the courses was about some queuing theory. I don't know, I didn't find this code, so I'm not sure what it was exactly. But you know, we had some exercise to simulate some queues. You know, it's like really like queuing people. I guess, what would you call this? What field of mathematics is this? You know what's not important? It's queues, and we had to do some simulation as a project, and I didn't want to use R. I didn't know R at all. So, but the simulation involved, generating random numbers, which is a very simple thing. Even then, it was, well-established field how to do that properly. But these random numbers had to come from various, distributions. Like in queuing theory, you use the exponential distribution a lot, so you have to sample from an exponential distribution, basically. So I started looking up how to do that, in different kinds of software and so on. And it was not actually so easy. If you, I don't know if the GNU scientific library, it surely existed back then. I don't know if it had already, the statistics. Probably not. I don't think not. Anyway, so I was, searching for something so that I don't have to code up something to generate, exponential random numbers, which is a small part of the project anyway. And I didn't want to use MATLAB because I didn't like MATLAB because at that time, I was working at a research institute and we just decided not to use MATLAB because we couldn't collaborate with other people because they didn't have MATLAB or they didn't have the money to buy it. We barely had the money to buy it, it was so freaking expensive. So I was looking for something, that was free and I could collaborate with other people and meet people and so on. So I found R. So this was in 2002. Oh yeah, I got a nice laptop, my first laptop, which was the old laptop of my advisor there, in the Netherlands. And he was really, really crappy. I think he basically hadn't used it for like 3 years when I got there already, because it was so bad. I think this was like from 10 years ago, 10 years before, I went there. Anyway, it was great. So it was my first laptop, it had Windows, so obviously I resized the Windows partition and then put Linux on it and then used it to do my project and all the other projects. So it was great. And then I found R. So R at the time was at this version 1.510. If you do R, that you know that there are a lot of oddities with R, and there are a lot of annoying things with R, and there are a lot of running jokes about this in the R community, like the strings as vectors, and a lot of these annoying things, which are funny. We can joke about it on Twitter and so on, but for new users, they're actually quite annoying. So you can't imagine how annoying this was, back then, 14 years ago. So just look at this. Oh, sorry, this one pointer actually. Yeah. So look at this one. It says, so this is the news file of this version. This one says, missingness of character strings is treated much more consistently, and the character string NA can be used as a non-missing value. This meant that actually from this version, you could have actually a character string NA representing an actual character string instead of representing a missing value. This is just ridiculous. Right? So this is when they had, from this point they had, the proper missing value, which is a great thing in R, but it was just not properly implemented before this version, for strings at least. Maybe it was for numbers, I suppose it was, but not for strings. And actually some of this you can still find, in the current version of R. So if you use the function read.table or read.csv to read in some data from the disk, there's an argument that says that's called NA string or something like that. And then you can set, the NA string, how your NAs are represented in the data file there. So that was the reason, why, because in the data files it was really hard to represent, NAs and missing values. Usually they just coded them up some way with NA. And then R basically itself couldn't represent, missing values. And that's just one of them, obviously. So there were a lot of annoyances, but seriously, it was great. So the first thing is, it looks strange, but I could just install it, it took basically 2 minutes to install the whole thing on Linux. And that was really surprising, so this was the time when, if you put Linux on a computer, first 2 days you spent with, recompiling the kernel so that, the mouse worked, and then the resolution was, something that you could actually see something on the screen and so on. And it was great, it worked, it could do graphics, which was very good, and basically among free software almost exceptional. So at the time we had Octave and we had Scilab, and maybe we had other things too, but maybe I just don't know. I don't remember them, or they were not as big as Octave or Scilab. Scilab, I think, could do some graphics, but not very good. And Octave essentially used this external program called GNU plot to do the graphics. And compared to the graphics, this is base graphics, just before you think about it. So compared to these base graphics, okay, this is a pretty messy picture, I agree, but So base graphics was great, you know, that you could do plots quickly. So it was a breeze to do this project in R, basically. That's the whole point. And then I left the Netherlands, and I forgot about it a little bit, actually, yeah, just to elaborate this point. So base graphics. So graphics is very important. So this is a tweet by the creator of the pandas, you know, Python library, and he's a Python guy, obviously. So he tweeted a Google Trends, you know, link that shows Google searches over the years for Ruby programming and Python programming, and clearly Python was winning, and Ruby was, you know, started to go down steadily. So he was really happy about that. So he tweeted that. He's good friends with Hadley Wickham, so obviously after that Hadley said, okay, let's put R in the picture as well, okay, just to see. And R is actually, you know, R, compared to Python, R is kind of niche, meaning that you wouldn't really use it for general computing unless there is some, you know, data involved. Maybe this is slowly changing, I don't know, maybe not. So anyway, so he put R on the charts, and he was happy too, because you see, R is below Python, yeah, that was expected, but it's doing very well, even compared to Ruby, which is also a generic tool. You know, that was great. And, you know, something got me thinking, because a lot of the new people, a lot of the people that were new to R I was talking to, you know, and I asked them how to use it and why they use it for, and then most of them just said, you know, plotting, visualization is great. So I was, you know, okay, so let's put ggplot on the chart. Okay, so ggplot is the green one. Okay, so in R, people just want to plot really. You know, and this is obviously not exactly correct, you know, because I don't know, various reasons, because you can, so there is actually a ggplot package in Python as well, so maybe that is included, although I don't think it's very big. And also the R programming term is somehow more specific, you know, so maybe if the R term, so that term should include things like R data analysis or R programming, you know, and R packages, blah, blah, all these kind of things, you know, because if you just do R there, if you just put R there, it's not a good search term, you know, it's getting better, but still in Google Trends, it's not a good search term, so you can't compare. Anyway, so this is interesting, you see, so a lot of people just want to do graphics, maybe not everybody, but this is actually good. Right, they come, you know, they start using R, they do the graphics, and then maybe they, you know, they find it nice, and they do the rest of the data analysis, and so on. So it's a good thing. Okay, so I forgot about R for a couple of months after I left, and I was in the US when this happened, still in 2002, I think, and my boss, you know, this network theory and complex networks, and that was a boom, you know, with Barabashi and many other people. So that was very popular. So my boss was teaching undergrads there, and various things, but he included networks, you know, in the things he was teaching, and he gave them some, and I helped him with the course when I was there. So he gave us some problems that were network problems, basically, that were unsolved, just, you know, for exercises and projects. And we started to work on a couple of them, and exactly as you would imagine. So if you have a problem that seems easy, but you don't know the solution, but it seems easy, it turns out actually it's not really easy. So we spent like the next 3 years, you know, answering some of these problems, and compared to that, the students did quite well actually. So, and for that we needed some software. So it turned out, just by chance, that R has some software already. It had a package, it was called SNA, for Social Network Analysis. It was written by social network scientists, obviously. For doing, you know, networks, basically. And it had a lot of things that we needed, so it was nice. And I didn't want to use R, but I found this package that was in R, so I wanted to, you know, it looked great, so we went back to R. But it was just a little bit slow, you know, it was classic social network analysis where the data is about, you know, a classroom, or maybe at most a small company, you know, people in the network nodes, and their personal or other connections are the edges in the network, and they analyze this data. And used adjacency matrices, which is a really wasteful format if you have a sparse network. Anyway, so it wasn't efficient enough for us, but otherwise it was nice. So I contacted the SNA main developer. He was a really nice guy, actually. And offered help, you know, by basically I offered him, you know, to rewrite some of the stuff in SNA in C, so that it will be faster and also use a different data type, you know, instead of the adjacency matrices. And he liked the idea, so he said, yeah, okay, let's work on that together. I was a PhD student, so I had plenty of time, all the time of the world, basically. So I just, went to coding and started it and, rewrote basically the whole thing, without telling him anything. Okay. So communication was not really great, from my part. But then a couple of months later, I sent him an email with a package, that, okay, you see, this is what I did from your package. There was basically no code left, from the original. And he completely freaked out. Obviously, it's not the way, to collaborate with people, He just had nothing to say. He couldn't say a thing. He didn't understand, what was happening, so he never actually replied this email. So what we still needed the software, so I just, started bundling it up, in another package, basically, and I called it iGraph because I suspect, I don't remember exactly, but I suspect the reason for the I was not the Apple hype, but it was because it was something like, okay, if you don't want my code, then I will do it. I think that's why, but I'm not entirely sure. Okay, so that was how iGraph came, and then I had a colleague who didn't like R. He's called Tamás, but he liked Python a lot. And he told me that he was also doing some networks, and he told me that he really likes the things I'm doing, but he really doesn't want to use R to do them. So if I would just remove the C, all the C code, create a separate C library, then he would write the Python part, and we could use the same code. Essentially, the two of us could write it. So that's why it's like 3 versions. There's an R package, Python, and the C library. So this became very popular. This is the first version, basically, as it's mirrored on GitHub now. This is not the first version on Clang. This is the first commit, I think, it's 12 years ago. And it was nice and small. And over the years, it became big and horrible. We added a lot of stuff, external libraries and everything, and learned a lesson, not to create such big packages, because it's just a huge thing to use. Anyway, I don't want to go into that. But just maybe one lesson that is very much R related. So that we learned from iGraph. Originally, because we had this C core for the package, and everything is indexed. All the vectors are indexed from 0 in C, and of course, as you know, if you use R, everything is indexed from 1, in R. But we wanted this to be very efficient. That was the whole reason, writing it. So we wanted it to be fast. So we didn't want to, convert these vectors somehow or convert the indexing. Of course, we were just actually looking back now. We were just not smart enough to do it, in a fast and nice way. So we did it in a fast and non-nice way, which means that if you use iGraph, still everything was indexed with zeros, in R, which was very annoying to me, obviously. And it was always annoying, but we just didn't dare to change it for a while. But then, this was much later, I think this was in 2011 or something. I decided that, okay, this is enough, so this has to change because it's madness to use, you're writing your code and you have vectors that are 0 indexed and you have other vectors that are 1 indexed. And you just make mistakes all the time. It's very hard for all mistakes. So I decided that this has to change, and we will need to switch to 1 indexing, even if that's a performance loss or something. Okay, so I don't know how many of you have created an R package ever? Quite some. Okay. How many of you submitted it to CRAN? Have it on CRAN? Okay, quite some. Okay, so for those of you who didn't, CRAN is a kind of old-fashioned repository in the sense that they like to keep things working. Okay? So if you don't follow this rule, very soon they start to hit you. Basically, if you want to do extreme things like I wanted to do, changing this indexing, this change, breaks all the code that is out there that uses iGraph. So it's just not allowed. You cannot do it because you can do it, but you cannot publish that package on CRAN because it just makes. So at this time, I think there were about 150 other packages depending on. So obviously it will break all the 150 packages and all the other code that is not on CRAN, that is out there. So that was not allowed. So there were two options. Okay. The first one was the proposed solution that I wanted, that I would create a package called iGraph0, which is compatible with the old behavior. Okay. So whoever already had the code, all they had to do is they had to change, the iGraph library, iGraph or whatever, when they're loading the package, and then refer to it to iGraph0, and then everything works. It's the same thing. It looked easy, I just had to email 150 people and convince them to make this, one letter change in this package. Okay, so I wanted to be nice with CRAN, so I asked them, what do they think about this, having this iGraph0 package? And then all of them, they said, oh, no way, no, you don't do that. These 150 people, 50 will never reply. So no, it will be a big mess. It's a lot of extra work for them, obviously, because they're continuously checking, testing the packages, and then out of a sudden, 150 will break, or maybe 100, because 50 makes the change. Maintainers make the change in time. So they said no way. They told me to create an iGraph2 package. Okay, so this is the reason why ggplot2 is ggplot2 and not ggplot anymore, and reshape is reshape2 and whatever. There's a bunch of packages that were rewritten basically from scratch or changed a lot, and they had to be renamed. And I decided, there's no way to develop software. It's just I looked at the iGraph name as a brand basically. I don't want to change that even to iGraph2, and then answer people's questions. So what do you use? Do you use iGraph or iGraph2? I don't know, what is the difference? I didn't want that. I wanted to have a nice iGraph0 that will be slowly forgotten, and so on. Anyway, so of course I did it my way. I don't even know why I asked them. I hoped that they would be okay with my solution, but they were not. But actually they were kind of nice. They went away with it. And a lot of packages broke and so on, and there's a lot of extra work for them. And about a year later, there is a CRAN repository policy which you have to comply if you want to have your packages on CRAN. So they added this sentence which says, introduction of packages providing back compatibility versions of already available packages is not allowed. So that's my contribution to the CRAN repository policy. So that's good, one of my life goals achieved. But it's an important point actually that it's really hard to break the API if you're developing R code basically or R packages, because there's just no way to. That's the only way to create a new package basically. That's the only way to do it. Okay, so why did R make it and others didn't? I was thinking about this as I was creating this tool, and I tried to remember what kind of other tools we used back then, Octave and Scilab. And this is entirely subjective, so it's just my subjective view. So I think there's at least two important points. The first one is that R was and still is open, and I don't mean only open source, but it's open in the sense that you can work with it. You can connect to it. You can use its features. You can rewrite its features. So some of these points. So it has a proper API both in R and C. It has nice documentation for this API. So there's this long document called writing R packages. So if you want to write an R package, what is it called? Yeah. Anyway, one of the manuals. Writing R extensions. Sorry. Yeah. Right. That's the. And it doesn't contain everything, but it's quite exhaustive. And back then, this was such a great thing to have. The other open source software projects, they just didn't have that. So either they really lacked documentation, or they had very outdated documentation, which is even worse than non-documentation. And R was just basically a breeze to use to people, and I'm sure not just for me, but for other people as well. And this is still true, although other software is catching up, obviously. It had a great package system already back then, and it improved a lot since then. So packages can do anything basically in R. So that's basically the main reason why the core of R or base R is not really changing a lot, nowadays, because there's no real need, for that, because you can just do everything, with a nice package. I'm not saying everything is easy, you know, to do, but there are ways to do it. It certainly helps that R basically has a single implementation, okay? So it's not like a language like Python, which is there is a language, you know, definition, specification, and then various people implemented it. And then, you know, these systems, even if they implement the same specification, obviously they work somewhat differently, especially regarding the parts that are not in the specification. Whereas with R, there is a single system, okay? So you download it, obviously you need to, you know, test different platforms and so on, but there's just one, you know, package, piece of software that you need to download, and then if you write something, if it works, you know, for that, that's good, you're good, you know, you're good with R. Anyway, so package system is great. There is a fantastic mailing list for that has changed a little bit, the mailing list. You know, this was before the times of Twitter and Stack Overflow, but a little bit shifted, you know, towards Stack Overflow and I guess other sources as well. So there actually somebody looked at this recently, and the mailing list traffic, just, you know, by a quick look at it, is going down. The amount of traffic recently is going down, whereas it was going up all the time. Okay. The other thing is, the second thing is that it was well tested, it just worked. Okay, so there was installation was easy, both for the base system and also for the packages. Okay, so if you use R, that you notice, you know, if you say install packages, some package name, that will just work. Okay, so if you type other things like you know, I don't want to, you know, be rude to other, you know, package environments and so on, but our languages are not always like that. You know, it also helps, again, the same point, that also for the packages, there's basically one central repository, and everything is there. And up to now, there is essentially one installer or package manager, if you like, in R, you know, to do it. So this restriction, basically, I'm sure it helps, you know, to make it more stable and make it work, you know, easier, but still the point is that it works. Packages are tested continuously. So it's like, you know, this is like continuous integration before maybe even this term was coined or got popular, you know, from the long time. So what they do in the prime package repository is that they don't just check a package that it, you know, okay, what check means exactly, maybe I will talk about that, maybe not, but it's, anyway, so they don't just check a package that is submitted to this repository, but they just check it over and over again. Okay, every day, basically. This is partially needed, actually, because that package might depend on other packages, and these other packages might be updated, you know, and then you need to check, you know, this dependent package as well. But even if it's not a dependent, you know, package, they just keep running this over and over again, and it's good, you know, and they are also ruthless about it, okay, the maintainers. So if something fails, it's not just, you know, an email to the maintainer that it fails. It's an email to the maintainer that it fails, and it's also, you know, another sentence at the end that please fix it in 1 week. Because if you don't, you'll be kicked out. Okay, and that's kind of rude, but it's really good for the users, and it's really good for stability. I don't have to say it's a pain in the neck for developers, you know, if you have a lot of packages, like you get one of these emails every week, basically, that you need to do something, otherwise you'll be. So they have the results of the checks and even the check times online. So somebody looked at this. This is a tweet. So it took almost 90 days of computing time to check all the packages on every operating system, you know, they use. Interestingly, about 35 days of that is Solaris, which is pretty slow. So you need to basically neglect that value a little bit. But anyway, so it's a lot of effort, and it just works. Okay, so these are all the good things. And in a lot of ways, you know, R and our package system was, I think, ahead of its time, you know, back then. But now, you know, technology is catching up, and other languages and you know, package repositories are catching up. So good practices are changing and evolving a little bit. So this is, I think, 2 years ago. I felt that there are actually some tools missing, you know, for R packages and for CRAN. So that's why I started this, what I call the meta-CRAN experiment. And one of the tools, basically, that I felt was missing was some kind of tool that helped me find, you know, the right package that I need for my work. So when I started using R, there were about, I think, 500 or so, maybe 700 packages, which is already a lot, actually. So if I want to go back again to the R versus Octave and Scilab, those have packages now too. I'm not sure if they did back then. I think they didn't. They do have now packages, and they have about 100 each. So these were big numbers already back then. And nowadays it's getting close to 10,000. So it's a lot of information there. A lot of packages do, just by looking at them, they seemingly do the same thing, or similar things, so you don't know which one is better, which one is not. Anyway, so this is difficult. So organizing information is obviously a hard problem. I will show you this example. How many of you have seen this? This is from 1994, I think, or something like that, 1995. So this is the Yahoo directory. So it's Yahoo even got its name actually from this product or software, web service, I guess. So it was a hierarchical directory. It was really a directory, So this is from the early time, or relatively early times of the internet. I'm not talking the 70s, but when it was starting to get popular all over the world. And then the people who founded Yahoo, they thought that, okay, so all these kind of websites, they link to each other, and it's all a mess. Okay, so we would just go ahead and catalog them, like a library does it with books. There are different topics and subtopics and so on, and they started doing that, and it was really useful. Okay, so people actually use this a lot. So if you wanted to find, scientific software, then you had to go, I don't know, I guess to science, or if social science, then social science, or if you wanted it for teaching, then maybe education or computers because it's software. So I'm not saying it was easy, but in theory everything was in there. But even then, it's not actually so easy to find. People were using this because there was nothing better. But then times, changed. Okay, don't go too far ahead. Let's not go that far ahead. Anyway, so times changed when did Google start? I think in 98, I think they started. And soon, in a couple of years, they actually partnered with Yahoo. So what happened is that if you use the Yahoo directory and you couldn't find anything, then you could just search. And Yahoo partnered with a lot of search engines. You could probably search actually the directory as well. You see, you could search here. So that was searching the directory. So that was kind of a search engine here. Anyway, but they also partnered with external search engines. So if they couldn't find anything in their own directory, they just used one of these external search engines. So they partnered with Google as well. And then around 2000, 2002, I think it happened that the search was just so much better than using because it was a better search algorithm. It delivered better results. So the people just wanted to do that instead of, just browsing the directory. And then Yahoo had to basically change the front page. So the directory still existed, but it disappeared. Okay? So the point is, if you have too much information and the information is just changing, too quickly, there's just no way that humans, can catalog it. Or even machines, if you don't have the algorithms that are smart enough, they just cannot do that. Okay? But it turned out that searching was a lot easier. Not easy, I mean a lot easier for if you knew the Google algorithm, I guess. But anyway, so searching worked better. That's what I should say. Okay, so just search. Okay, so I wanted to search. Okay, so I created a database and indexed all the metadata about all the packages, and then created this R package. It's called CER. It's called. I'm not very good with naming packages. And it has a command which is called C, and you can just say C image and then how many results you want, and then it gives you some results. And the important thing here is that it does ranking. Okay, I'm not saying this is perfect. Obviously, it's much less sophisticated than Google search engine, but it does ranking. It ranks according to number of dependent packages. So if a lot of people use your packages, a lot of other packages use your packages, that means you're probably better, so you get a higher score. And also according to the number of downloads, which is possible because RStudio has a parameter that provides download numbers. Anyway, so that is ranking, and it finds relatively good results. I mean, it could be better. So that's how the Metacran thing started. This is just using the download blocks. You could use an API to access it, but then some people use that API to build some nicer visual tools to just to download number of, just visualize number of downloads over time for some packages and so on. This is probably an artifact in the beginning. Anyway, the next thing was that in addition to search, I also wanted to read the code that was there on CRAN, because I wrote a lot of R codes. I wanted to see what other people do, how other people did it. Because that's a great way to learn. I think one of the most beneficial things of open source is not that you get it for free, but you get to see, the actual code, and it's an enormous learning opportunity to see how, Helleviken or Jeroen or somebody who knows a lot about how to do something, how to do it. And you just copy it, of course. You don't have the right to copy it. Okay, so GitHub was nice. We already use GitHub for iGraph at this time already, and basically almost everybody was using GitHub. So I thought, okay, let's just do, let's just mirror CRAN on GitHub, the whole thing as it was, and as it is, so continuously updated. So I put, every CRAN package is in a separate repository. Nicely, this is continuously updated. I need to have a warning that this is not the actual repository, it's just a read-only mirror. Everybody loves GitHub, right? So look at these bright young, R programmers. Loving GitHub. Every package, in its own repository, has every version is a separate commit, so you can compare versions easily. You can search, so you can search all the code. So you just say you want to search the CRAN organization, and you want to search for supply, and then you find basically all the uses of this function, which is great if you want to learn something. Okay, and then if you had all this, I had all these tools, so it was really easy to put a relatively nice website on top of that. It looks relatively nice, but it has a lot of glitches. It's like with everything. If you have a project, it takes like 20% of the resources, the time and work, to create something that looks great, but has some little annoying things. And then it takes, the 80% of the time to fix all the annoying things, and I didn't actually take that 80% of the time to do that. Anyway, so you can search here and browse and so on. Yeah, that's the single most popular. So nobody really uses, all these. I mean, I don't know how many people use some of them, but surely the website doesn't have very much traffic, so people don't really use it. But everybody uses it. People just love these badges, about the download numbers, and I have another one for the CRAN versions, and we could have one actually for package checks as well, easily. So anyway, so that's the single most popular, service of MetaCRAN. Okay, I have about 5 minutes to talk about this, the R project and the R Consortium. So the R Consortium, I think, started last year, right? Last year at user, I think, was officially announced. So what is the R Consortium? R Consortium is a bunch of companies that put together money to make, okay, how do they say that? To help with support and coordination of the important activities of the R community. It's pretty broad. So the R Consortium is basically the main sponsor of this meeting, of this conference we are at. Okay, so they're doing this kind of things. They're also doing, they have some working groups, if there are some features in R that basically don't need money, to develop, but it just needs some discussion, to bring people together, so they support that, with some project management kind of support. And they also support software projects, and one of them that they support is the R project, which I am doing basically, almost half of my time. Okay, so what is the R project? The R project is, the goal is to help package developers and to help CRAN itself, the CRAN people, by automating some of the things that they are doing, basically almost manually nowadays. It has a lot of pieces. It's a very big project. It was obviously overly too ambitious, but anyway. So basically, one of the parts is a build and check service, to which you can submit your package, and it will check it and test it for you on a bunch of different architectures. So this is kind of painful to do for yourself. If you use a Windows laptop to develop your package, it's kind of painful to test it on OS X and Linux and vice versa. So this is a good service. So the way this works now nowadays is that, I mean, you can obviously, there are other services you could use, but mostly of the way it happens is that you submit your package, you test it on your own architecture, and then grand people say no, sorry. It looks like, especially if you have compiled code, R code is usually okay, but if you have C code, C++ code, that's usually problematic because the compilers are just different. So that will tell you, no, sorry, you can't publish this on CRAN because it doesn't work on Windows, or it doesn't work on Solaris, or it doesn't do this and doesn't do that. Even if those things that it doesn't do, they were clearly required, in the CRAN repository policy and so on, which is not an easy read actually. Anyway, so it will help you with that, So I can show you how it works instead of having this boring. Oh yeah, this is. Okay, this is good one. So you can do it from the command line. So you need to validate your email. That's already happened. And then once your email is validated, you can just say, so this is a local package. You are now inside the directory of a package, of an R package, and then you can just say check. And then what happens is that it compresses all the directory into an R package and uploads it to RHub. And then RHub starts checking it. You can specify the architecture. There is some default. I didn't specify it here for this demo. You can specify the architecture that you want, Linux, Fedora, and R version, I don't know, 331, whatever. And then it starts doing that. So if you develop R packages, then you probably have seen or know about the RCMD check, tool, which is basically a package check that you are expected to run before you do your CRAN submission. And it's a useful tool, even if you don't submit CRAN, because it will tell you, about a lot of different errors. This just keeps going on. So it's just, installing all the system dependencies and then the other package dependencies for this package that I'm checking and so on. So this is a completely isolated environment. This is Linux, so it's in a Docker container. And then at some point it will start running RCMD check if everything is, installed for it. And then you can do the same with an upload, web interface. You can do the same as a CI, so like a continuous integration service. If you use Travis CI, it's very similar to that, but it's R specific. So which means it's somewhat nicer if you use R because it will install the dependencies for you and install the system requirements for you and so on. Okay, and it's done. Okay, so it's sending an email to me in the end. It says success in the end. It's actually not correct because there was some, oh sorry, the GIF starts again. So there was some mistakes in that. Anyway, so that's one of the main things in RHub, and I barely have enough time. So final thoughts, 1 minute. Okay. Actually, I'm just 41 minutes now, actually, but anyway. Okay. So what about the future and where are we going? RHub is not ready, obviously. So all you have seen is basically experimental. A lot of things work, but they're not really production grade. So there are errors. Not all system dependencies are installed correctly, and so on. There are a lot of errors. Actually, most important omission is that only Linux currently. I'm very close to Windows, but Windows is just very difficult to do in an isolated way. It doesn't have Docker, so that's why, basically. Anyway, so yeah. So what's the future? Where are we going with all this? And what is that is still difficult, and we want to, or we could, improve. So packages are still difficult. I won't go into the details of these examples now, but for most people, even experienced R users, they don't even know if they put some code, in an R package, then they're not sure when that code actually runs. Okay. So because there are so many stages, there is a build, there is an install, there is a load, when you load the package. So when does it actually run? What do you think? Who thinks it's at build time? No, that's good. Install time? You have no idea, probably. Okay. I didn't know this until like 3 years ago. So at load time? Clearly you have no idea. It runs at install time, actually. Okay. It's not completely intuitive, and it has problems and catches, but I don't go into that now because I don't have time. Okay, so it would be nice to ease the burden on the package maintainers on CRAN, which is obviously one of the main goals of RHub. And hard to find the right package still, documentation search is improving, and so on. Can we compete with Python and JS, other more generic languages? And I don't want to compete them, for generic computing, just in this niche or small but growing field of data science or data manipulation. can you compete them? Because they're getting a lot of tools. You know? So this is a quote from Tim Berners-Lee, which is basically telling you that the less powerful the language, the more you can do with the data. So it's good to choose actually the least powerful language that you can do your things. Okay, so but the reason I showed you this is because there's a funny, some of the joke, but a funny corollary, which is Edward Slow, he's a blogger, founder of Stack Overflow, says that, so that's the corollary, every application that can be written in JavaScript will eventually will be written in JavaScript. And we are getting there, but I think R is in a pretty good position. It has a very mature foundation, you know, in the R internals, basically. The implementation is kind of messy, but the concepts are nice, and that's important. Standard libraries are written, those are also kind of messy, but they're written with by extension packages, so by, you know, the headliverse/tidyverse and so on. Has great graphics, has a great GUI now with RStudio and other GUIs as well. More open than ever, you know, with RHub and so on, and better tested than ever. So, looking forward to the bright future. So, R package developer.
Thank you, guys.
Any questions first, not the bright future.
Any quick questions?
Come on, it's just 45 minutes on my laptop. 50 minutes.
Right, any questions?
So you set up Metacron. Obviously, that was fantastic before that.
Yeah.
So maybe how do you compare it to? What are your thoughts on that? Can you review?
Yeah. So that was another kind of similar service. Hadley did this with a student, I think. I think it was a Google Summer of Code project, which is called Fantastic. It has some similarities. It had a nice website. Obviously, it had to be backed up with a database, so they had a database too. So I think it failed basically. No one really uses it, you know. I'm not saying people use Metacran, and that failed too, maybe. I'm not saying it didn't, but Fantastic surely failed. A couple of years ago, one or two, I got an email from Hadley, and he said that maybe I should just redirect, you know, Fantastic to Metacran. No needed. And so Metacran is much more open. You know, you have access to the database with an API. You have access to the download logs with an API. It's really easy. It's a nice and easy API. Fantastic is basically a website that you can use. You can't really use any other services. You know, not even the badges. I don't know if this is good enough, you know, for Metacran to succeed. The most probable future for Metacran is that it will merge somehow with RHub. You know, in RHub we also promise to have some kind of website where you can search, you know, and browse and stuff like that. And it will be actually a waste of time to revise much of that, because that part is actually quite well written that I did for Metacran. So that will just be merged. Yeah. Good.
Thank you very much.
No, wait.
Go ahead.
Well, on a similar note, how do you compare SEER and SOS?
Oh yeah, the search. Oh yeah, no ranking. SOS. Yeah. You know, so it gives you a lot of stuff, and it's just almost useless if you have 9,000 packages. You know, only if you have some very specific terms. Also, they're searching different data, kind of. So they're in SOS, you know, so you search for package, you search for functions essentially in the R packages, which is useful. I'm not saying it's not, but it's kind of a different thing. And it's also not ranked. There's no ranking. So that's just for a lot of things it makes it useless. You know, so I wrote iGraph, so you know, I wanted people to find it. So you know, if I wanted a search engine where you can type in networks, and then it would give you, oh, look at this great package. You know, if like 250 other people use it, it must be great, right? Yeah, no, actually, but anyway. So, but SOS, you know, doesn't do that, and there were no other tools that did it. And you needed the ranking for that. If you do SOS networks, it gives you a lot of relevance, but not good stuff. All right.
Sorry guys, the schedule is extremely busy, so use the networking time, coffee breaks and lunch breaks. Feel free to talk to Gábor and ask other questions. Let's thank you again for this great keynote.